The last thing I want to discuss for our introduction to derivatives is different ways that we denote the derivative of a function. Right now, we have said that the derivative of a function is the slope of the tangent line of the function, which is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And from the last video in our practice with limits, you should realize that, hey, I'm taking a function, f of x, I'm doing a function rule to it, which is this limit thing, and I'm ending up with a function as its result. Well, that function has another name. If my original function is named f of x, we can name the derivative of the function f prime of x. That eliminates the need to write the slope of the tangent or this entire thing as saying what you want. We also know that another name for f of x in some cases is y. So another way to denote the derivative is y prime. If I want the derivative at a point, which we did in our last video, we would write what point I want the derivative of. For example, if I wanted at x equals 3, we would write f prime of 3. Again, if I'm using the y and the y prime notation, I could write it as y prime of 3. Another way that you may see it is if the original function is f of x, you may see it written as df dx. Okay? So this is pronounced df dx. So this has the same meaning as the derivative of f. If I want to evaluate this at a point, I would write df over dx with a vertical bar, and I write what point I wanted to evaluate it at. Using the y notation, I could also write this as dy over dx, so dy dx. And again, if I want to evaluate it at a point, I'd write dy dx evaluated at x equals 3. Sometimes you may see that they don't just use the name of the function, but they actually use the function. For example, if f of x is equal to x squared, these two notations would stay the same, but these two notations I could also write as d over dx of x squared. So if I actually want to use the function for either one of these, that's the way, another way I could write it. I could write d of dx of x squared. And if I wanted to evaluate this function at a particular point, it could be written as d over dx of x squared evaluated at x equals 3. What you understand is that there are various representations of symbols for the derivative and the derivative of a point. And your book and the lectures that we do for this class will use these different forms for different problems. I just want you to understand that, hey, that, and that all mean the same thing.